Okay, so I'm going to put up here some things under each of these that is a potential cause or potential problem. And then these are all things that we are going to be testing in the future. We're going to start today actually with compression testing, and we're going to go outside and use that engine trainer to do it. But we're going to go ahead and outline all these. So we'll start at the very top. The intake stroke is the very first stroke. So what actually happens during that stroke? The intake valve opens, the piston is traveling down, and when the intake valve opens, what's supposed to happen is it's supposed to suck in an air and a fuel mixture. Now the air is in the atmosphere, so it's never going to be missing unless you have some type of a major restriction in the air inlet. But what can happen is the fuel component. So the engine that we're working on out here is carbureted, but modern engines are fuel injected, which means that you're going to have an individual fuel injector for each cylinder. So during that intake stroke, if the fuel is not being injected into the intake plenum or into that intake runner, it could be a bad fuel injector. It could be an unplugged fuel injector. It could be a faulty electronic connection. It could be a blown fuse. It could be low fuel pressure. So we've got a ton of fuel-related potential issues, but we're going to save those for later. And so we'll just put that for now. We're going to research that stuff later on. Once we get into basic fuel and ignition systems, we're going to be learning how to test fuel pressure, how to test fuel injectors, and how to do cylinder power balance tests and all that stuff. All right? Now, compression, this is what we're going to be starting to test today. In order for an engine to operate, it has to be in good mechanical health. The intake stroke sucks in that air and fuel because as the piston travels down, it creates a low pressure or a suction where the rings are sealed to the cylinder wall. So the piston rings have a job to seal the cylinder and to also help control the flow of oil into the cylinder. So, compression. This is measured in cylinder pressure. And cylinder pressure is required in order to make an engine run because that cylinder pressure is what puts the squeeze on that air-fuel mixture to heat it up. So cylinder pressure. So we could potentially have faulty mechanical components such as rings, damaged pistons or cylinders, and we could also have leaking valve train components. So we could have a valve that's not sealing or seating all the way. During the compression stroke, that chamber has to be completely sealed off in order for it to work like it should. Okay, during the power stroke, we have that ignition event occur. So we can have faulty ignition components, bad spark plugs, faulty plug wires or coils, bad connections, electrical issues, blown fuses. And then down here at the bottom is exhaust. We could have a plugged up or stopped up exhaust. But we're going to save all that stuff for basic fuel ignition. Today, what we're going to focus on is here. We're going to see how the cylinder pressure tells us the health, the mechanical health of the engine, and we're going to do two things. We're going to perform a compression test. And we're also going to perform what's called a cylinder leak down. Okay, so during a compression test, you get however many cylinders you have, you're going to measure the cylinder pressure in each cylinder. And then you're going to take that information and you're going to compare it. So there is no necessarily perfect number. There is a percentage or a guideline that you must follow. So we are going to measure cylinder pressure, and we're going to compare the readings. And let's say we have 8 cylinders. So all 8 cylinders, if all 8 cylinders are doing the same amount of work, that means that all 8 cylinders should be producing the same amount of power, and therefore all of these cylinder pressures should be within reason of one another. And that within reason is usually 10%. So if we take a reading on 8 cylinders, all 8 of those cylinders need to fall in the number range of 10% of one another. Okay, so let's say, for instance, that we find a cylinder that is low. If we find a cylinder that is low on cylinder pressure, that means that that cylinder is not sealed up or it does not have the ability to generate pressure. And there's a number of things that we can do to try and rule out what the problem is. So the reason that we start with this test is because this test does not require you to disassemble the engine. It just requires your knowledge and understanding of how the engine is supposed to work. So we are going to measure cylinder pressure on 8 different cylinders. We're going to write those numbers down, and then we're going to take our comparison and see if it's within 10%. If we find 1 or 2 that are low, then we're going to move here. And what we're going to do at the cylinder leak down test is we're going to force a metered amount of air into the cylinder, and if it can't generate pressure, it can't generate pressure for one of 2 reasons. Reason number 1, the rings are unable to generate pressure because they're simply worn out. And to try and see if that's accurate, we can do what's called a wet compression test. The second reason is that the cylinder pressure is being generated, but it's leaking or escaping somewhere. So the cylinder head bolts down to the top of the engine block. We have a head gasket in between those 2 surfaces. It's possible that that head gasket could be leaking. So we are going to test that with a leak down test. It's also possible that our intake or our exhaust valves are leaking due to weak or broken valve springs, burned valves, or valves that are not seated, bent valves. So if air starts to escape from the intake valve during a cylinder leak down test, you will hear it coming out of the air filter area. And that would tell you that you have a problem on that cylinder with the intake valve. And then you can investigate a little further. If we hear it coming out of the exhaust valve, coming out of the exhaust pipe, then that tells us the same thing on the exhaust side. We also can see if we just have excess pressure going past the rings into the crankcase. So if we have an excessive amount of pressure start to leak out of where we pour the oil in, that tells us that the crankcase is getting overpressurized and we could have a broken piston, a broken ring, a cracked piston, something like that. So these 2 tests combined together will give you a very good idea of what mechanically might be wrong with that engine. And then you can make an assessment from there. If you have something mechanically wrong with the engine, it's going to require you to disassemble it and fix and repair that particular part of the engine. So if it's a valve, for instance, you might be able to remove the cylinder head and have a valve job done, which isn't too terrible. But if you have a broken piston or a broken piston ring, that means that you're going to be tearing the entire engine down, probably buying new pistons and rings, having the engine block machined. That's a much larger process than simply having a cylinder head removed. So at that point, it might be a better option for you to just simply replace the entire unit. If a customer needs their car back, they can't afford to have their engine at the machine shop for 8 to 10 weeks. So it might be a better, more cost-effective alternative for you to buy a remanufactured engine or a used engine, install the whole thing in the vehicle, and then the job's done. Now, what you also have to consider is what led to this problem. So, if you have something that has a blown head gasket, why is the head gasket blown? One of the most common causes is because it's been overheated. The customer might not tell you everything. They might bring you the car and just say, hey, my car's running bad. Can you fix it? You find out it's got a blown head gasket. You replace that, and then you go test drive the car, and it overheats. It could be overheating because it has a faulty water pump. It has a leaking radiator. It has, 100 different areas where water or coolant could be leaking out. That might be a secondary issue that led to this bigger issue. So you may have some other things that you have to address when you start making these types of repairs. I have had situations where people create their own problems. Like, for instance, somebody tries to replace an air filter or an intake manifold or something like that in their driveway, and when they get done, they're missing a bolt. Can't find it, don't know where it went. Well, that bolt accidentally fell down one of the intake ports. When you put it all back together and start it, that bolt falls down on top of the piston, and it destroys itself. So how did that happen? You take the engine apart, you find a broken, wadded up bolt inside the cylinder. Had stuff like that happen before. There was nothing wrong with the engine until it got worked on. So these are the things that we're going to focus on today. And we're going to go outside, we're going to do that on this test engine. So make sure that you have a pair of safety glasses on, and we can go ahead and head outside. Oh, grab that battery right there. No, I always do it by hand. Yep. Yep. Bye. All right, so yesterday, come on over here. Yesterday we established that we got this engine running pretty good. When you do a compression test, you're really supposed to do it with the engine warmed up. So we're going to start this thing up and just let it run for a few seconds, and then we're going to proceed with our test. So what we're going to do is we are going to remove all these spark plugs, all 8 of them, and then we are going to crank the engine over. Now, anytime that you're doing a compression test, you got to remember 2 things. If you're working on a modern car that's fuel injected, we're going to be cranking the engine over for a long period of time. So we don't want those fuel injectors firing. We don't want it flooding the engine. So we don't want the engine to start either. We just want it cranking. So what we have to do is we have to disable the spark and the fuel. So that may require removing a fuse or a relay so that it cuts off the fuel injectors during this test. On this engine, it's carbureted, and it has a distributor. So all we have to do is disconnect the coil wire and then not pump the carburetor, and it won't deliver fuel. So this is going to be a little bit simpler than if we were working on that car right there. So we're going to remove all 8 spark plugs, and then we're going to proceed with our test. But first, let's start it up and let it run for just a minute, put a little heat in. this has larger spark plugs, so they're 13/16. And you can go ahead and pull your spark plug wires off and remove all 8 spark plugs carefully. Try not to drop any of them. The toolbox is over there. We'll roll the whole thing over here. Two size spark plug sockets. Common ones are base. These are 13/16. So that'll put you in the spot. Here's the rest of them. Spark plug sockets. Just pull off. Be careful with it. One that fits yours. This one should fit the other side. We're going to pull all 8 of them out. Just set them down here. Just pull that up. Pull all 4 of them. Take the spark plugs out. Put the solid already on the spark plug. Take the rack out. Set it down there. Pull the spark plug out the socket. Yep. Your spark plugs a lot of times can tell you what your engine is doing. So if you pull the spark plug out and it's covered in oil, it's not a good sign. This one is, they're black because it's rich with fuel. This is our compression tester. Yeah, newspaper or something like that. we're going to put a battery charger on it because we're going to crank this over multiple times. We want it to remain consistent. So if you don't have a battery charger on it, you'll start on one cylinder and your readings will be good. By the time you get to the A cylinder, the engine will be cranking slower because the battery voltage is low and your reading might be off. So we're going to put this on there. Avoid that. All right, get all the way to now. Our compression tool's got a bunch of different sizes. So we want to look at our spark plug and choose the appropriate one. So we've got two different things to look at. One is the physical thread size, and the other one is the reach. That's how far the spark plug goes in. So if you look at these two, that is the correct thread. But so is this. So see how much longer that one is? This is for like a Toyota or a lot of imports. The reach goes further into the cylinder. So if you put this one in here, the piston could come up and hit this and damage it. So you want to make sure that you match up your tool with your spark plug. Make sure you have the appropriate thread and the appropriate reach. Alright? Now this has a little check valve in it, kind of like a tire valve. So it's going to put pressure in here and then it's going to hold it. So we're going to start over here. And we're going to follow along and we're going to write down each cylinder. So this is an old GM engine. All the odd cylinders are on one side. They're labeled here. So we got 2, 4, 6, and 8. And then we got 1, 3, 5, and 7. So we want to write that down on our paper. So write down 1. And then underneath that a 3, 5, 7, and then 2, 4, 6, 8. We want to make sure that we write down the appropriate cylinder pressure on the appropriate one here. So if we start on this one, just because it's on this side, we're going to start on cylinder number 2. We're going to screw this in by hand. It doesn't have to be super tight. It's got a hold it on. And then we're going to put our gauge on it. Gauge just flips on. Make sure that we're on 0. Just got a little valve here to relieve pressure. Now, we want to make sure that we do this consistently. So every cylinder, we want to make sure it turns the same amount. So this is a 4-stroke engine, which means that you're going to hear 4 revolutions of that piston going up and down, especially since there's no plugs. So when you do this, just count to 5. That'll ensure that you get all 4 revolutions. You'll also see it on the gauge. It'll pump up, up, and then it'll stop. So cranking it any longer is not going to get you a higher number. But not cranking it long enough will give you too low of a number. Alright, so we're going to make sure that our ignition is off, and we're going to crank it. Now if this was a fuel-injected car, we would have to disable the fuel injectors, but this has a carburetor, so it doesn't matter. It also doesn't have any fuel in it because we ran it out. So we're going to count. 1, 2, 3, 4, 5. Okay, so we got through all 4 movements of the piston, and then this gauge is analog, so you've got to kind of guess. We've got 150 and 200. So we've got all these little marks in between. So that would be 160, 70, 80, 90, and we're in between there. So we're at 55, 65, we're about 175. So 175 PSI on cylinder number 2. Okay, now we're going to relieve the pressure, and we're going to move to the next hole. I'll let you all do the rest of it. So we're going to screw this out, and then we're going to screw it right into this next one, and the next one, and the next one. We're going to record all our readings, and we should be within 10%. Each cylinder should be the same, or very close to the same. look at on that? So, yeah, it's pretty close to the same. It might be 173, just under that mark. What you want to look for is a drastic change. So if you get to the next one and it's like 120 something, that's a major difference. If you get to one and it's 180, it's not a huge change. So each big line is 10. Right? So you got 1, 2, so that's 50, 60. So the first big line after 50 would be 160, the next one would be 170. So this is probably about 172, 3. Not quite 175. Now move to the other side, record all 4 readings, and then we'll assess what those readings are. Just getting the numbers is only part of the test. Being able to determine if it's good or bad is the next step.
Somewhere around there. Yeah, but
Okay, so now, after you get all your results, you want to be able to determine if it's good or bad. So on a test, you might see a test question that has all these numbers, and it might say, Technician A says, the test results indicate a good healthy engine. Technician B says that this cylinder indicates a problem. So, we've got all these numbers, and we want to look for a drastic change. So, what I like to do is I like to take all my numbers and find an average, because you're always going to have one cylinder that's a little better than the others. So, if we take all these and we get all these numbers, we can probably average about 178 to 180. We got a high of 190 and a low of 192 or 3. Okay, so let's just say that we have an average of 180. We need to be within 10% of that. Okay, so what is 10% of 180? Okay, I'm sure you have figured it out really easy. 180 times 0.10. So this is 10%. So do that on your calculator. Anytime you want to find a percentage, you can multiply it by the decimal. So 1% is 0.01. 10% is 0.10. Okay, so 18. All right? So that means that we need to be within 18 numbers. 10% equals 18. All right? So do we have any in here? So let's say our average is 180. So 180 plus 18 would be 198. And then 180 minus 18 would be how much? 180 minus 10 would be 170. And then minus another 8 would be 162. Okay? So our lowest reading could be 162. So do we have any here that are even close to 162? No, they're all way above that. And then our highest reading, we don't have any that are close to that either. So we're well within our 10% range, which indicates that this is a good, healthy engine. So this is important, because what you would want to look for, like I said, are drastic changes. If we were going down through here and we had one of these that was 120, that would indicate a problem on that cylinder. Now, another thing to look for, you've got these cylinders that run in a row, right? Okay, so we got 4 holes underneath that cylinder head. And each hole is producing cylinder pressure. So we've got cylinders 1, 3, 5, and 7. This is something else that I've seen on tests a lot. So let's change our answers here a little bit. Let's say that cylinder 1 looks great. Cylinder 3 is low. Cylinder 5 is low. All the rest of them look perfect. Okay? If you have 2 cylinders that are adjacent, which means side by side, and they both indicate low pressure, what's the most common thing, or the most likely thing, in between these 2 to fail? You've got a gasket that goes in between the cylinder head and the engine, right? So we have space here. If you have a situation where you have 2 cylinders that are directly next to one another, and you have low numbers on both, what that usually indicates is that you have a blown head gasket right here. So the cylinder is low because it's passing those cylinder pressures back and forth. It's not sealed. Now, if you had a low number here, and then a low number on 7, that wouldn't be the case, because those 2, you're not going to blow a gasket from here all the way over here. Same thing from side to side. So if you had a low number here and a low number here, it couldn't be the gasket. It would have to be something mechanical. All right? So all of this indicates that this is a good, healthy engine. So we've done our compression test, we've done an assessment. Keep in mind that these numbers don't really mean anything. You could have numbers of 150 across the board. That would be low. But if all 8 of them are within 10%, that indicates it's good. The cylinder pressure is directly related to how the engine is assembled. So if you have an engine that's like out of a race car like this, it has a domed piston. It's probably going to have a little bit higher cylinder pressure. It also has to do with the camshaft duration and how much overlap the cam has and stuff like that. But the number is not as important as understanding the difference between the numbers. You want to make sure that you're within that 10% window. Okay, and if you're not, you want to assess why. So if you have two cylinders side by side, it could be a head gasket. If you have one cylinder all by itself that has a problem, that could indicate that it has rings bad, or if it has a valve train problem. Now, the next thing we're going to do is we're going to test and see how well the rings are sealed. So the next thing is called a wet compression test. A wet compression test is the same as a dry compression test, which is what we just did, except we're going to inject or squirt a little bit of oil into each cylinder, and we're going to repeat the process. Okay? Now the reason behind that is, we'll say this is dry, and then we're going to take a wet reader. Alright, so we've got our cylinder, right? And inside of that cylinder, we've got a ring. Ring goes around. Tiny cap. Now the ring's job is to seal the space here. Well, over time, cylinders become ovals. They get out of round. And then the rings can't do their job very effectively. So what a wet compression test does is we're going to take a little bit of oil and put it in the cylinder. And that oil is going to fill up this void right here, this gap. So let's say that we have one cylinder that has a low number. If we put oil on top of it and then the number jumps up, that tells us that the rings are leaking because the oil that we just put in there is filled with void. Now, if we do a wet compression test, if all of our rings are good, what we should see is all the increases should be relatively close to the same. So anytime you do a wet compression test, you're going to see the number go up. But again, what you're looking for is a drastic change. So we should see a small change here on a wet compression test. All of our results might go to 190. If you had a cylinder on 120 and you did a wet compression test and it jumped up to 170 or 180, it's because the rings are now sealed by the oil. Does that make sense? Okay, so let me get you a little bit of oil. Okay, we're going to use transmission fluid. You can use motor oil or transmission fluid. All we're going to do is put this in the hole. We don't have to put a lot, just like a teaspoon, not even that thimbleful would be more accurate. We're going to take this, it's already poured. We're just going to give it one little shot and then repeat the process. Same thing at each hole and record the wet reading. So cylinder number one, we went from 175 to 180. So on a good set of sealing rings, you're not going to see a major change. It's always going to change some, but it's not a huge number. So on each one, it's going up about the same, somewhere between 3 and 5 pounds.
Number 8, it's got 185.
Alright, so look at your results. No drastic changes. They all went up about the same, right? Roughly 5 pounds. But what was it to start with? Okay, so it went up a little higher than the rest. So that indicates that that particular cylinder could potentially have little bit of a ring seal issue, but it's not enough to cause the engine to run poorly. It is different than the rest, but not enough to make a major impact. All right, go ahead and screw all your spark plugs back in. Put that back in the case there. Make sure you screw your spark plugs in with your fingers and then tighten them in.
Don't use that toilet. For now, you do it. It's weird. I see what Christian. I don't know his last name. Hector? Yeah, I think. Yeah, he's got a Confederate flag. Blah, 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 blah.
Huh?
Yeah.
There's a what?
Confederate flag. Blah, blah, blah. Last year, he was like the exact opposite of my section. Last year, he wore like
Yeah, last year
shorts
he
every
did.
day and had a turn. Now he wears boots.
No, I was like, what? Because you can drive around.
You're gonna go in my way to loosen. Move up a little bit.
You don't have to get them super duper tight either. So good. do a lead down test tomorrow and do an analysis on that as well. Go ahead and get your